Alright guys, welcome to your weekend notes. This is the weekend of November 9th, 10th, and 11th. My goal is to actually keep these notes to about 5 to 7 minutes. We're just going to go through a few vocab words for technically, basically kind of categorizing polygons into a couple different ways. Alright, the first one, as you can see on your screen, is a regular polygon. This is what most of you think of when you think of a regular polygon. Right, the official definition is that it is a polygon that is both equiangular, that's a fun one to say, and equilateral. I know you've heard of an equilateral triangle, means all sides are the same. Equiangular means all angles have the same measurement. So a regular polygon has all sides the same and all angles the same, equiangular and equilateral. All right, here's an example for you. Most of the shapes, when you think of a shape, when you think of a polygon, you picture in your head a regular polygon because that's what you've been trained to think of. When I say, oh, there's an announcement being made. When I say octagon, you immediately picture a regular octagon, okay? You always have to trust the marks on a picture. You cannot go by just the picture. So this top left, what is this? This top left hexagon here, I cannot assume that it is regular. I have to have those markings. Remember we did that way back in the day. We talked about you can't assume that sides are congruent. You have to have the markings that show it. Same for angles. Angles have those little half circly looking things. All right. So the picture in the bottom right of your screen that says all of those angles are the same measure and all of those sides are the same length. Of course, there is then something called an irregular polygon. Right? Basically, it's a polygon that's not a regular polygon. So all polygons can be classified as regular or not regular. You may see on some standardized tests, ACT, etc., they may use the word non-regular instead of irregular, but it all means the same thing. So, regular, not regular. Even though it's a rectangle, we're so used to seeing rectangles. We're like, oh, a rectangle, that must be a regular shape. It's not, because what makes a rectangle very specifically a rectangle is that it has a pair of congruent sides and another pair of congruent sides, right? A rectangle is not going to be 12 inches on every side. It's going to be 12 inches on the top, maybe 4 inches over on the side. So they're going to be different lengths. I'm talking the video. Say hi to Cassie, guys.
Hi. Can you put on my number? Because Mr. Miller is being mean.
Your number?
Yes. Because he posts our grades.
Sorry, guys. Pause. Just fast forward it. Oh, your ID number? Yes. Give me a minute. I'm literally making a video right now. It's their notes. It's what they watch over the weekend.
Okay.
Can you come back in like 10 minutes?
Oh, he's probably on a bell ringer right now.
Oh, okay.
Can you just text it to him?
Yes. All right. Concave. Concave, right? Think of caving in, right? What's a cave in? Caves in. Things go inside. Officially, your definition is if any part of the diagonal contains exterior points, meaning if I can connect the diagonals, connect non-consecutive vertices, and it crosses outside of the polygon, it's concave, all right? See if I've got my little animation here. Where's my little marker? All right, here's one corner, right? Let's see if I can get this with the mouse. And here's a non-consecutive vertice, right? Because there's a corner in the middle. When I connect that diagonal, it contains points in the exterior. It goes outside the polygon. That is a concave. Same with over here. I could connect this corner. This one is a non-consecutive vertice, and when I connect those, it is outside the polygon. Convex is the ones you almost always think of. When I say shape, you think of a convex shape. If no diagonal contains points in the exterior, right? And we did this earlier today. Well, for me, it's earlier today. For you guys, it was, 2.5 days ago. But every diagonal I connect on this shape, pretend these are straight lines. I'm doing this with the mouse. All of these only are in the interior. They never cross outside. None of those diagonals go outside of the shape at all, and that is what makes it convex. So, this one, convex or concave. So I think to myself, I can always just tell by looking, but I could always check, right? All right, so this one here, well, it only has one non-consecutive corner. That's this corner. Oh, hey, that diagonal stays inside the shape. okay? But if I go to the next one, this corner down here, and connect with its non-consecutive vertice, bam, the diagonal goes outside. So I gotta get rid of this silly ink. All right, so it is concave. This one over here is, in fact, convex. Okay, so those are your two new words. Well, two, I guess, two pairs of words. You have irregular versus regular, and concave versus convex. And look at that, only 5 minutes. Even with having Cassie come in and having a conversation, she had no idea what I was doing. She was very confused. So I hope you guys have a good weekend. I hope you enjoy your what's going to turn out to be 6 minutes of my voice. Those of you who are watching this, I'm sure you know what's coming up on Monday for the bell ringer. Just a hint, be ready. You're probably going to pick out some of these things. So have a good weekend. See you in a few days.